So we're back in Visual Studio so we can implement the token authentication. I'm going to start out by creating a constructor for our attribute because we want to be able to store some data that can be passed in when we're using the attribute. In this case, we want to pass in a Boolean that says, should we authenticate per user, in other words, use our basic authentication, or just allow people to use the API if they just have the token-based authentication? Typically, both of these are going to get married together. The token authentication is going to be used to figure out who the developer is and whether they have access to the API, and then basic authentication in order to determine the user of the API so that we can do things like return the right diaries for that particular user. We'll go ahead and just store this as a local field. So in our authorization, there's going to be two steps really. There's going to be authorize it using token authentication because we're going to require anyone with this attribute to use token-based authentication. And then once the token authentication has completed, we'll go ahead and allow the per user authentication. So to do this, let's go ahead and wrap all of our existing authentication that is user-based inside a if per user. So that this will only be valid and checked if per user is true. So let's talk about what that looks like. Let's make sure that per user is true by default. So we're going to give it a default value. That way, when we look at where we included it, like in the diaries, it will be per user by default. But this is going to allow us to go back to something like the food controller and add counting K's authorize with false as a parameter to say, hey, we don't need to do user-based authentication here, but we do need to authorize it for the API users. Not for the actual users of our system, but that the developers that are using our APIs must have an API key and have gotten a token and using it. Hope that makes sense. So back in the authorize attribute, we have this little piece where it's checking to see if it's per user. And if it's not per user, we can go ahead and shortcut out of here. And we can shortcut out of here because if we've already gotten to this point, we've done the token-based authorization. We're about to add this outside of this if per user. So how do we do this? So what we're going to expect is that when a user calls our API, let's say nutrition foods, that we're going to expect that they're going to pass in a parameter for their API key and token. So the API key is just the same key that we gave the developer when we originally registered the developer. And we'll just pass it in on the query string to make that easy. And the token will be that token that was passed back here. Go to raw and let's grab that token. And let's go ahead and change this to a get. Get rid of the content type and get rid of the body. Because now we're just going to implement a get, but we're including the API key and token up here in our parameters. So that means back in our code we need to do a couple of simple things. First, let's create a couple of strings for the name of the parameters we're looking for. And I'll do another one for, because we're going to need them in a couple of places. Next, we're going to want to be able to get the query string, and we can use HTTP utility to do that. We can parse the query string from the action context.request.requestURI.query. And this is going to return to us a name value collection. So we can go ahead and test to see whether we have them passed in. If not, string empty or white space, query, API key name, and not string is null or white space. Then we can actually process this. We have the query string. We can go ahead and put the end of this if way down here. And we'd probably refactor this into a couple of methods to make it not a giant method like we're doing here. But let's, because of our time constraints, let's do it this way. Now let's go ahead and pull out the API key and the token. So we want to go ahead and use that token and get the auth token. But in order to get the auth token, we actually have to have an instance of the repository, just like our controllers do. So if we go ahead and create a new property down here, and let's add the using we need here, then we can use that repository to go ahead and get our token. And we're going to pass in the token. If the auth token doesn't equal null, in other words, we found it, then we can verify that the auth token.APIuser.appID includes the same app ID that was passed in, API key, and finally auth token time.expiration is greater than date time.utcnow. As long as the expiration is greater than now, we're going to allow it. In fact, this is all we need to do. We've gotten the token and the API key from the query string, and once we're happy with it, we can pass it down to do our per user authentication if necessary. Now we can go ahead and test this, and we're going to find immediately that the repository is going to be null, because we provided a place for the repository, but we didn't provide a way to get the repository in there. So we'd like to be able to use the dependency injection we were using earlier. We can actually, but figuring out exactly how the filters are going to get this dependency injection is going to require a new class. So to prepare for it, let's go ahead and use an attribute called inject. This is going to support something called property injection. Because construction can't be controlled by ninject because the construction is part of the attribute, we need to have a way to take the object that is the attribute and tell ninject to go ahead and find all the properties with the attribute of inject and try to fulfill those services. In this case, supply it with a repository, and this should happen before authorization happens, so that when we get down here to look for our token, that the repository isn't null. But how does that happen? What this requires is that we build a new service, and this new service is going to be injected into the pipeline of what happens inside Web API, so that when the filters are provided for, we're actually going to implement a filter provider, we'll be able to look at all of the attributes for a particular controller, look at their filters, and then be able to supply dependency injection to those filters for them. So we're going to create a new class called an Inject Web API Filter Provider. This is a sort of class that probably will eventually be supplied by either the framework of Web API or be supplied by the Web API Contrib project. One doesn't exist yet, and I may even submit this to them to include there, so you don't have to actually write this over and over again. For our example, I just want you to see how the pipeline actually is being used. So I'm going to implement Filter Provider. This is an interface from system.web.http filters. This is the Web API version. And this is going to simply have a call that says, get the filters for our system. And let me fix up some of the namespaces. So based on the configuration and the action description, how can we go ahead and get all the filters that are going to be required? And the benefit of doing this is we're just going to gather the existing filters for the controllers, and then before we pass them back in there, we're just going to use dependency injection to push any required services into the filters before we pass them into Web API to pass off and do the work it needs to do. So I'm going to go ahead and just paste some code so you can see what this is doing. We're using the action descriptor to go ahead and get all the filters that are for controllers. We're also using the action descriptor to get all the filters that are for actions. And then we're building a list of them by just mixing the two. We're concatenating the controller filters with the action filters to get a master set of filters. From there, we can just do a quick for each and then do the injection. This has us just return that filter collection. So again, what we're seeing is finding all the filters, doing the dependency injection, and then passing back those filters. This is just a plug-in so we can get into the middle of that operation. In order to do the injection, though, we're going to need the ninject kernel object. So I'm going to create a constructor here that's going to take the iKernel object that's in ninject and just store it as a local field. That means for the injection, we can then just do kernel inject. The provider's in the filter .instance. This is the instance of the object that we're going to inject using dependency injection into whoever needs it, in our case, the property. Next, we need to register our filter provider with Web API. So just like we supported Web API earlier by using the inject resolver, we're going to do a similar thing here by adding to the services of the configuration a new filter provider. Bring in that namespace. And this is just going to be a new instance of our class, and because we have access to that kernel, we're going to go ahead and include it in there so that the filter provider we just wrote can use it to do the injection. If we did this right, then when we come down here and get to pulling out the auth token, the repository shouldn't be null. It should be fulfilling it with the same sort of request that we're seeing when we build our controllers. So let's see if we've done it right. Yep. So because the API key and token are on here, it's authorized. I've taken them off and I'm getting a 401 from our project. And if I put them back on, we can see we're getting a nice 200. And if any part of this is wrong, let's say I add an extra equals at the end, which is obviously going to make it broken, it's going to bring back the unauthorized. Now we could give them more information about what is authorized or what is not authorized, but that's really up to us. So ultimately what we've done is we've added the ability to pass back tokens and then use the same filter mechanism to be able to test those tokens. And in the case of user-based calls, so let's go back to our call for user diary. I'm going to drag it over to the composer so we're generating it again. If we execute it like we did before, it'll actually say unauthorized. And the reason is we may have our user information here, but we do not have our API key and our token. Remember, they're working together in our authorization attribute. So now that we have both of them together, we're getting the actual data. Because it's checked to make sure that the developer is valid. So it's authenticated the developer as well as using the basic authorization header to validate the user. The last piece of this puzzle that you should actually do, now that we've added a separation between token-based and per-user-based authentication, is down here in the handle unauthorized. The inclusion of the www.authenticate response header is only really valid when we're doing per-user authentication. Otherwise, pushing them to a login page doesn't make any sense. So it's usually pretty helpful to just go ahead and protect this with if per user. The unauthorized is still appropriate in both cases, but this unauthorized will only apply to the developer being unauthorized in the case where we're only using token-based authentication, where we're not using per-user authentication. When we are, we're going to go ahead and include that header that we saw back in the basic authentication example.